Okay, align with the green line at the trailing edge.
Copy that, holding tension.
Looks good. I'm starting the roller.
The automated gantry system precisely dispenses a consistent bead of high-strength aerospace adhesive along the bond paths.
Data confirms guide pin engagement.
Adhesive compression looks nominal across the forward spar.
Ensure the alignment is perfect on that sensor. The tolerances are tight.
Confirmed. It's seated correctly.
Initiating gimbal calibration sequence. Stand clear.
Telemetry looks nominal. Rotation check complete.
Lock the handle firmly. I'll connect the ribbon cables now.
Handle secured.
Pressure holding steady at 5,000 psi.
Clear on the hydraulics, no signs of leakage on the main strut.
The inert gas test ensures the structural integrity of the wing tanks before final assembly.
The audio features a switch in between modes that rates people. Flap cycle complete, aileron check passing. All deflection angles are within tolerance. Looks good.
Broadband emissions are spiking right at the cutoff frequency.
I see it. Adjusting the polarization now.
Flow rate is stable, pressure holding steady.
Visual inspection confirms no leakage in the internal compartments.
We are at max Q, thrust verified.
Affirmative, green across the board.
Rivet cluster 42, clear.
Sensor array nominal. Check.
Wing leading edge feels smooth, final sign off on panel 9.
Watch the leading edge, slowly now.
It's settling into the cradle. Secure the forward straps.
Keep it steady on the left. Copy that, watching the clearance. Keep it coming.
The final clearance is complete.
Understood. I'll ensure immediate dispatch.
The MQ-9 Reaper, equipped with Hellfire missiles, represents the pinnacle of modern aerial reconnaissance and precision strike capability.
The lightweight Nomex honeycomb core provides extreme rigidity and structural strength to the fuselage.
The flexible bore scope allows the technician to meticulously examine the critical bond lines deep within the fuselage structure.
Here we see the technician sliding the shock piston into the main housing. Now we test the steering movement.
The technicians meticulously install the cooling system, ensuring the composite ducts align perfectly with the turboprop's intake.
Watch the alignment as it goes in. Looks good. Pass the torque wrench.
The technician uses a precision alignment tool to ensure the pitot tubes are parallel to the center line for accurate airspeed sensing.
We have a clear thermal bridge developing near the nozzle.
Noted. Rerouting coolant flow now.
The alignment data is holding steady at 0.02.
Confirmed. The gyroscopic output looks nominal across the axis.
Easy now, bring it down another 2 meters.
Watch the alignment on the coupling, and we have an issue with the seal.
Cradle is locked in. Start the tension sequence on the forward straps.
Engaging ratchet. Tension at 500.
The integrity check passed on all modules.
Confirmed. We are cleared for deployment.
feed is perfectly stable, even with the rapid movement.
High bandwidth confirmed. Test successful.
Running diagnostics on the flight sticks now.
Clear on the sensor side, we are good to go.
All right, snug it up tight on this side. Copy that. 3 more clicks on the binder.
Handing over the final documents, congratulations.
A magnificent achievement. We'll take it from here.